Everything I just said. All right. How do I find that slope? y2 minus y1. Who decides which is which? Who? You do. What's the mistake some of you are going to make? You're going to mix up which is which. If you make this guy y2, then what's this guy? y1. If you make this guy y2, then what's this guy? y1. Does it matter? No. As long as that guy's y1, so what's that guy? x1. And that guy's x2. Now, the only other mistake you're going to make is, as always, you're going to not write it down. The ones of you that don't write it out are going to have a 50-50 shot of getting the wrong answer. If you write it out, it's impossible. y2 is what? 4 minus y1 is what? 3 over. x2 is what? 2 minus x1 is what? Negative 10. Then you're going to make a second mistake here because you all think that you can add and subtract in your head. But you can't. Because a bunch of you, even though I'm making a big deal out of it right now, are still going to tell me that this answer is negative 8. A bunch of you. It's not. What is it really? 1 over 12. Right? Right. And that would have been worth 2 marks. 1 for remembering the formula and 1 for applying it properly. What's the key word in number 4? Parallel, which means what? Same slope. So, I need to know this slope, don't I? How do I find a slope when something is written that way? You put it into slope-intercept form. 5x minus 3y equals 12. What has to be by itself? Y. So, do I even care about the 12? Why? Why don't I care about the 12 here? 12 is the y-intercept. I only care about the slope, don't I? So I don't even need to worry about the 12. So I'm going to get rid of them. So all I got to do is get y by itself, right? 5x equals 3y. Now what? Divide it by 3. And what's the slope? 5 over 3x. That is the slope I need. And that would have been out of 2 marks as well. Now, what if I asked for the equation? Then would I need to care about the 12? Yes. Should I just do the perpendicular one, finish off the page? Okay. Again, I only care about slope, right? What's the key word here? Perpendicular, which means the slope has to do what? Not negative. It doesn't have to be negative. Opposite and reciprocated. So once I know this slope, what do I do to that? Flip it and that's the flipping. Make it the other sign. Opposite reciprocals. So I have 7x plus 2y. And do I care about the 10? No, because I only care about slope, yeah? So I can get y by itself. So go. That's going to equal 0 because I don't have to care about the 10. What do I got to do with the y? Get it alone. So how do I do that? Huh? I got to move the 2y away, don't I? If I move the 2y over here, what happens to them? 7x equals negative 2y. Now how do I get the y by itself? Divide by negative 2, divide by negative 2. So what's my slope? 7 over negative 2. But I don't want that slope, do I? What slope do I want? I need perpendicular, so I flip it to what? 2 over 7, and I change the negative to a positive. That's the slope I care about. And that one would have been out of 3, because you would have had to do all the same math and remember to flip it and change the sign. Everybody good? Making that whole first page out of 9 so far. Now, there were 2 more questions. Go. This one. More than one way you could do it. Yeah? I just put it there because it's another way you could have done it. Okay? You could have graphed that point, right? -5, -2, and then counted from there, yes? To have a slope of -2/3, I could have gone down 1, 2, and right 1, 2, 3. To that point right there, which is -2, -4. That's one way you could have done it. You could have graphed it. Or you could remember that the 2 is the change in y's, right? So as long as my y's did -2, I would be good, yes? Which of these are my y's? That one. So I could do -2 from that to get -4, -6, -8, -10, and so on, yes? What else could I have done? Could I not have gone the other way? Could I not also have done -2, 0, 2, 4? And those are y values, right? Now, if I did minus y's, then what was my x, my run? Would it have to be positive or negative? Positive if I did minus y's. So my -5 would have been +3. -2, 1, 4, 7. Yes? But if I did positive 3's or positive 2's, then what would my y's, my x's be? The x's would have to be negative, and it would have been -8, -8, -11, -14, -17, and so on and so on and so on. You could have done it with graphing or algebra. Everybody good? Whichever way you did it, I would have given you 2. I wanted only one other point. I am betting that all of you had that one or that one, is my guess. And finally, if though this is a right triangle, then there's perpendicular lines there, yes? Do I check all 3 corners? Of course not. I sketch it out first. Where's point A? 1, 1, 2, 1, 2, 3, 4, down, 1, 2. Where's point B? 1, 2, up 1. Where's point C? -1, 2, down, 1, 2. Which of them looks to be 90 degrees? B. So I have to check the slope of CB and the slope of AB. And if it's 90 degrees, what happens? Negative reciprocals. So I check CB first, which is -2 minus 1 over -2 minus 2, which is -3/4. Yes? Right? Is it -3/4? Look closer. What's -2 minus 1? -3. What's -2 minus 2? -4. What do 2 negatives make? It's +3/4, right? Okay. And then I check AB. which is negative 2 minus 1 over 4 minus 2. What's negative 2 minus 1? Negative 3 over 4 minus 2? 2. Are those negative reciprocals? No. So is this a right triangle? No. Everybody good? Oh, don't worry. I'm going on. Everybody good? Excellent. And that would have been out of 3 because you would have had to check it. So that makes the whole thing would have been out of 14. And I may or may not take marks for that. We'll see. But we are going to move on. Everybody turn to 198. All righty. If I want to graph a linear function, I've given you guys 3 ways to do that, yes? In the 9th grade, how did you learn to graph a line? What did you use last year to graph every line? No, that's how you actually drew the line. How did you know where to put the ruler? Excellent. How did you know where to start that line? From coordinates. And where did we get the coordinates? From? No. Where did you get the coordinates in the 9th grade to draw a line on a graph? Okay, so according to you, if I have a piece of paper, I can... Yes, and what did you do to get those coordinates, Rihanna? Then say you can't remember. Nobody can remember last year how you drew a line. If I gave you this and I said, draw this, what did you do in grade 9 to put this onto a graph? Because you did not learn slope-intercept form in the 9th grade. You might have learned rise over run. What did you do with this to put it on a line, on a graph? I'm perfectly calm because I only taught a few of you grade 9, so I don't need to feel too bad. I'm a little sad that Connor, Carlin, Connor and Carlin, oh, and Vicky aren't saying anything right now. Oh, and Daniel. Not one of you could put this on a graph from the 9th grade. You find the coordinates. What did you use to find the coordinates? Okay, so go. Tell me. Give me some coordinates for this graph. Someone. I am begging you. Input some coordinates into this graph. Yes, we know that one, but that's grade 10, Aaron. For you, and for you, probably grade 4. I'll emphasize the word again. Input a coordinate into this graph. You can't be worse than saying nothing. Yeah, I do remember the input-output thingy. Oh, so go. Input a coordinate. -1. That's an input. So where would it go? X. Then what? Then what? Great. What is it? Which is? 4. Excellent. So we have an x of 1, -1, and a y of 4. Input another coordinate. 4. Where would that go? For x. So what would be the y? 19. Excellent. So what do we do with those inputs and outputs? We make a table of values. X, Y, -1, 4, 4, 19. And now we could graph it, just like we learned last year, right? You did tables of values last year because I used to walk into your class every day and I saw tables of values drawn on the board every day when you were doing linear functions. I know you can't remember. That's kind of the point of what I was doing here. That was, you brought that to grade 10, yes? You all brought tables of values to grade 10. Some of you called them T-charts, but you all brought that to grade 10. When you arrived in grade 10, at the beginning of this unit, the first way I taught you to graph anything was using what? Intercepts. Oh. X and Y intercepts. That was the first thing you learned in grade 10. Then, when you learned X and Y intercepts, using that knowledge, we realized, oh, wait a minute. When X was 0, the equation gave us the Y-intercept, didn't it? So then, the third thing you learned was Y equals mx plus b, which is called slope-intercept form. And that is where we are right now, yes? Okay. Now, to do these things, you need coordinates, right? What is common between 2 and 3? They both use intercepts, right? But how many points are on a line that aren't the intercepts? Or I'll change that question around. How many intercepts does a line have? Only 2. And how many points does the line have? How many more than 2? Infinite. So doesn't it stand to reason that there must be a way to graph that uses the other infinite amount of points? There is. It is called point-slope form. And we are going to write it out first and see if anything that you see there makes you think about anything that you already know. Everybody with me? All right. This is point-slope form, and it is number 4. It uses any point on the line and the slope. It doesn't just use intercepts. And it looks like this. Does that look like stuff that you have seen? What on there looks familiar to you? All of it. Y2, Y1, X2, X1. What are they? They're points on the graph. They're coordinates. What is M? M is the slope. Everybody cool? All right. So, this is how it works. These 2 points give you the point on the graph where you start. Now, in slope-intercept form, where did we start? If I was graphing something in this form, where was the first dot that I put on the graph? The y-intercept. And then how did we graph it? What did we do once we put that dot on there? You'd know the slope and you count up and over or down and over, right? So in this form, we don't start in an intercept, we start at this point. And then how do you think we graph it? I shouldn't be hearing silence now. How did we graph from a point here? We use the slope. So how do we graph from a point here? We use the slope. From which point? The one that we started at. Now it gets a little weird here. Watch. I'm going to give you an example of this. Y minus 7 equals mx minus 3. Right? Everybody cool? Okay. Now, where do you think you would start this graph from? You think you would go to -3 and -7, right? All right. So let's just work with me here. Jasreed says we should go to -3 and -7 down here, right? Everyone agree? Yeah? Okay. So that point is -3, -7. Agreed? And it's an x and a y, right? What letter do you see there? So what could I write there? From this point. -3. Everyone cool? Okay. -3. And what could I write there? -7. Does everyone agree? Okay. If I say my slope is 1, what would happen here if we use -3 and -7? What is -7 minus 7? -7 minus 7 is 0. -14. So this side would be -14, correct? And it would equal 1 times what's -3 minus 3? -6. Does -14 equal -6? This is not a trick question, guys. Is -14 -6? No, -14 is -14, isn't it? So we cannot start at -3, -7. So, I'll ask again, we've tried one thing with an experiment. What is another thing that might make sense to try here? I need these two sides to be equal, don't I? Okay. So what could I put in for x and y that would make them equal? If I use the same number, for example, 4 minus 3 is 1, 4 minus 7 is -3. Does 1 equal -3? No. So I can't do that. What else could I try? Zero minus 3 is -3. 0 minus 7 is -7. Does -7 equal -3? No. So it can't be 0. I've already told you that these guys are the hint. These guys are the point where you start. You tried -3, -7. What else might you try? +3 and +7. All right? So that would be out here. 3 and up 7, correct? Let's try. What goes in for x from here? 3. So I would have equals 1 times 3 minus 3, correct? What would go in for y? 7 minus 7. What's 7 minus 7? 0 equals 1 times, what's 3 minus 3? 0. Does 0 equal 0? Yes. So what does that tell you about these 2 points? This is the equation, but I needed to start at 3, 7. So what does that tell you about those 2 points? I had -7, -3, but I needed 3 and 7. So what does that tell you? You start at the opposite. And that makes sense, doesn't it? Because just like in slope-intercept form, if the y2 is a negative, we still do minus minus 2, don't we? Right? So this is saying negative. It's the opposite of whatever y1 is. Does everybody understand? So the hint, like Carlin just said, the point on the graph where you start, but you have to remember to switch the sign. Everybody cool? Let's see. Does this does this look like this? Excellent. So where do I start my line here? Close. What goes first, X's or Y's? So I start at 1, -2, and what's my slope? -2/3. So if I were going to graph it, what point would I go to? 1, -2, and then do what? Down 2, right 3, and up 2 and left 3. Everybody cool? All right, that's going to take us to the end of the day. Your homework is to finish filling in page 198. Just page 198.